Hello, my name is Luke Hasty. I work for Nuaware. We are a specialist distributor who help our customers and partners understand and adopt new technologies. Our specific focus is on the world of cloud, DevOps, and containers. We've been doing this since 2016. Today is the first in a series of short videos which go through some of the foundational concepts in this new world. First up, I wanted to set the scene around how and why companies are all now building software and why managing and maintaining that software is difficult. So starting with that, why are we building more software? Why is that hard? This new drive for a software-oriented world is coming from consumers. Smartphones, mobile computing, digital native, millennials. These are people that are used to interacting with their favorite brands and the world via the internet. The way that you do that is through software applications. A guy called Mark Andreessen, famous VC, he coined this phrase, software is eating the world. And what does this mean? Basically, the premise here is that those brands and organizations who can offer a great software experience to their customers will beat out competition in their market. So there's a few examples of that happening already or has happened already. Blockbuster and Netflix, Uber dominant over traditional cab companies in a lot of places. Airbnb emerged in the hotel scene. Spotify gives you access to millions of records at the tips of your fingers. And then Amazon, death of the high street. You're now competing with a business where a few clicks on your phone and practically anything that you could want arrives the next day at your house. So every company is becoming a software company, or they should be, because otherwise they will lose out to organizations that can offer that sort of experience. So this video is a little bit more information on why is not every company just doing this, why is it difficult, and why do we see some of the failures and outages that we see in the real world, considering that some of these are the biggest companies on earth. So what makes up an application, and why do we have failures? So this is our end user device. This is how we're interacting with the world now. And yes, there are familiar applications that you could be using on your device. Now some of the more common ones, gaming and digital native platforms, Uber and Netflix, but also people now want to pay their mortgage on their phone. Going into a branch to pay for a deposit or withdraw cash is not something which is familiar or commonplace to a digitally native customer base. So we're talking about applications which are broad and far-reaching, with lots of different requirements around compliance and governance, as well as uptime and things like that. On the other side of this, there's also enterprise software. These are typically products which are used internally at large enterprises, either to power some of these customer-facing applications, or your customers may be considered other departments within your business. If you're the payroll company, you have every other employee as your customer. So how does this process work? We have an application. Your application has customers engaging with it every day. The business looks at that application, and in this example, we want to make an update to our existing app. This could maybe be releasing a new feature or changing the background color in response to an event. Basically something the business has decided is good to drive more sales or more customers or a better experience. So how does that process work? So we have our example application that the business looks at. The business defines a list of requirements, takes those list of requirements to the team of developers. These developers listen to those requirements and they write some code which will achieve that business objective, change the background color, adds a new feature. That code is then compiled into an artifact. That artifact is stored in a central repository, and from the central repository, it's there for other areas of the business to use for stuff like testing. So when that testing is done, that artifact is built into the application and it is deployed. Customer then upgrades their application and has access to their new feature, new color, whatever it is that the business has decided. From there, the business observes the outcome of that. Did it lead to more sales? Did it lead to new customers? And the feedback loop starts again. Do we need to change something else? And you go through this cycle over and over again. This is the iterative way that we build software. So that seems simple enough. However, applications are very complicated things, and they do require a lot of under the hood system code to work. Now, developer time is very valuable. So in order for developers to spend as much of their time writing new business focused code and not on the operational side of application code, what is developed is the way for a business to abstract a lot of that operational software stuff into a separate software layer. This layer basically takes care of a lot of the day-to-day operations under the hood, which allows an application to work. Now, this software itself has to be installed on an operating system, Windows and Linux, we're familiar with. Now, that operating system, at the end of the day, has to be installed on a machine somewhere, on some infrastructure. Now, that could be cloud infrastructure, that could be virtual machines, that could be on-premise machinery. There's always hardware somewhere at the end, but as a business, there's different ways of consuming infrastructure now, which mean that might be virtual. So this is known as the technology stack or the application stack. And all of these layers need to be in sync for the application to run correctly. That application has been developed with certain versions of software and operating systems in mind, certain requirements, certain configurations. So this stack needs to stay consistent. Otherwise, we're going to have a problem with the application and customers aren't going to be able to access it. Where it gets more complicated, however, is that the software and the operating system and the infrastructure are all going through this same feedback loop themselves. They are software, they are applications, updating features, security patches, that sort of stuff. And then on the infrastructure side, usually there'll be new business requirements aimed at reducing cost or improving security, which might change elements of the infrastructure. So we can start to see how this stack and maintaining this stack for our applications starts to become more and more complicated. Oh, and let's not forget that we need to secure all of this. But I said applications are complex. So there are usually multiple parts to an application. Think a shopping cart, front end, customer account information, different languages. What that means is there are usually multiple application stacks at play. And those application stacks need to talk to each other. Now, how do you do that? You need more software. Middleware is software which operates as a communication platform for the application, but that itself has versions, it needs to be maintained and managed, etc., etc. Lots of applications require customer data to function. This data is stored in databases, which is yet more software, it needs to be managed, it needs to be maintained. And these parts, let's not forget, also need to be secured as well. Now, unfortunately, it doesn't end there. You now have your application running, customers are accessing it, but what happens if your data center or your infrastructure loses power or your cloud region goes down? Your application is going to stop working, which is bad news for a gaming application who might lose revenue per minute for however long your infrastructure is down, your application is down. Or what if your application is in use by hospitals or air traffic control or power stations? It can't go down. So what businesses do is they build for failover. Another data center which will take on the load if the other one goes down. You now have twice as much software and infrastructure to manage and maintain. And if any element of it fails, you need to find and fix it because your application is at risk of going down. Now, companies don't want to be in that position where their production application is at risk of going down, or one of their data centers has failed, they want to do as much rigorous testing of these applications as possible prior to that application going live, that deployment, that upgrade happening. So the way that they do that is they build another environment, which is your testing environment. This is in most cases, reproduction of your main production environment, and you run your application here, and you do things like increase the load, see how things behave, ultimately to test that all of these application stacks are in sync and your application performs like it should do. The final element to this is that developers, when they're building applications, they want a bit more flexibility. They don't want to be constrained by the chance of things going down, or having to maintain that sort of fixed reproduction of the main environment. They want their own environment where they can be flexible. They can change stuff. They can break stuff. It doesn't matter. They're trying to get this application to do new things. They want a bit of flexibility to be able to do that. So as you can see from that one application stack, we've now got, potentially 4 full data center or cloud environments, which all need to be managed, maintained, updated, and secured. This is where enterprise IT, big software vendors, partners come into play, because enterprises really need help doing this. This is where our partners and Nuaware comes in to help. This is complicated. This is massive, and the potential ramifications are huge if you get this wrong. Fortunately, IT has been around quite a long time. There's lots of smart people that work in technology, and there are things and technologies and tools which have come about and make our lives easier. There are modern ways of developing applications, so using automation and different tooling and methodologies to ensure that we're building applications in a quicker, safer, more stable way. We now have infrastructure at our fingertips. No longer you are sat waiting for a truck to arrive with your new infrastructure to start building your application. This is Amazon again. You have got cloud infrastructure available at your fingertips in minutes. And there are actually new modern ways of actually running the application. So these are ways which allow things like disaster recovery and scalability and resilience to be built in to the application through automation tooling. So that's about it, setting the scene on why applications are complex and why organizations exist to help with this. The rest of our series of videos from Nuaware and the team are going to be digging into these concepts that I've just talked about on the left in more detail. What are the modern ways of building and monitoring and managing applications and software in order to make your life as easy as possible and deliver that great software experience that your customers are looking for. Thank you very much, and speak to you soon.